When you live on the Pacific coast, you learn that earthquakes are just a fact of life.
Earthquakes are common here in Southern California and all around the Pacific Rim.
But most of them are not that damaging, and many of them are actually too weak to easily feel.
But keeping track of them helps scientists map out where the stronger ones will occur.
An earthquake occurs at a fault in the Earth's crust, and a fault is a crack in the crust where the two sides are moving at different speeds.
Faults are not always visible at ground level, but scientists can map out these faults by keeping track of seismic data.
That's why we're here, in Pasadena, California, at Caltech Institute in the Seismological Laboratory.
A seismograph is an instrument that helps record waves of energy that travel through the Earth, called seismic waves. See? Cool,
Oh,
right?
wow, look at that. When a seismograph records an event, it records the wave pattern as well as the time of the event.
Scientists have learned how long it takes for different seismic waves to travel through the Earth, so they can calculate how far away the earthquake was from the seismograph.
But a single seismograph only records the distance to the event and not the location. An event happens somewhere on a circle with the radius to the distance.
That's where trilateration comes in.
Try a later vacation?
Very funny. Trilateration. When you know where a point lies on 3 circles. You can find the point geometrically just by knowing the center and radius of each circle.
Oh, yeah, I was just testing you, of course. But we can easily demonstrate this at the workshop. Let's go check it out.
Let's do it. This is an example of an earthquake and how trilateration works.
This earthquake happened in 1994 in Southern California, right in the center of the San Fernando Valley.
We have 3 seismographs mapped, one at the center of each circle.
Now, the radius here represents the known distance from the seismograph to the center of the earthquake.
You can see that there are several points shared by 2 circles. The blue and orange one intersect here and here.
And the blue and green intersect in 2 places, and the green and orange intersect in 2 places.
But there's only one place where all 3 circles intersect. That is the epicenter of the earthquake.
The Northridge earthquake was so devastating, partly because it occurred in such a populated area.
According to the Southern California Earthquake Center, this was the first earthquake to strike directly under an urban area since 1933.
And it occurred on a blind thrust fault.
That basically means that the fault line is not visible at the surface.
But when we use seismographs and a little geometry, scientists can see below the surface and locate the epicenter.
And by mapping the many small earthquakes that happen every day, they slowly build up a picture of the fault lines in the Earth's crust. So, Tony, have you ever been through an earthquake?
Yeah, actually I have. I was in the 1994 Northridge quake. But you know what? With proper planning and monitoring, it's nothing to get shaken up about.